All right, great. And so we are live. Well, hey, parents, as you know, my name's Gray Matthews and I run Empowered STEM. Empowered STEM is a company that offers A-level chemistry revision courses for those students that want to earn an A star in A-level chemistry so that they can attend the medical, dental, and veterinary programs of the choice of the chosen university in the UK. So look, just wanted to come into the live stream today, have a chat and get a hang with, because coming down with a bit of head cold here, so the voice is just about to go. But I want to get in, and I did want to answer a question. All right, so after the last live stream that I did, the question is, yeah, well, Graham, you know what? Um, you was talking about conceptual clarity, and you're talking about inorganic chemistry and how it helps, my year 13 student, understand A-level chemistry, get that A star. Can you go into a bit more depth about that? Well, the answer is yeah, sure. So here we go. All right, so sticking with the idea of inorganic chemistry in year 13, and specifically, let's take shapes of complex ions, all right, which is a topic that students find a little bit difficult. So shapes of complex ions. If you look at shapes of complex ions, what you notice is that it does depend on a couple of things. Number one, the size of the transition metal ion, number one. Number two is going to be the size of the ligand. Number three is going to be the type of ligand. And then number four, it's going to be the D subshell splitting. All right, so you've got four things you've got to cover. And so, when we're working with our year 13 students, they can write. And so what we do is we look at this, and it's kind of like from a top-down approach. And so this is like the top thing. These are the four concepts they've got to understand. But these concepts, they're supported by what I call it's like supporting concepts, all right? And so, for example, if you take size of the transition metal ion, the size of the transition metal ion depends on charge in the ion, +1, +2, +3. It also depends on the location of the element on the table. And so what you need is that you do need to understand the trend in atomic radius, all right, in the periodic table from year 12. Number one. And then number two is you do need to understand the idea of orbital contraction, which is basically when the atom loses a valence electron, then the size of the atom begins to get smaller and smaller. And you need to understand the reason why, okay, as you take away more and more valence electrons, okay? So number one is you're thinking the size of the transition metal ion depends the location, the charge, the location of the element on the table, and the charge of the ion, number one. Then number two, if you go into the size of the ligand, now the size of the ligand, we really don't get into this in A-level chemistry, but it is worthwhile doing a little bit of a deep dive on it. The one thing that I have an issue with the A-level chemistry textbooks is that they do tend to gloss over a few things. Like, oh, well, just kind of like take that on faith, or you'll get this. Just like memorize this, but you'll get this in university. No, you can explain it in a way that the A-level student understands. So you got the size of the ligand. So, for example, the chloride ligand is larger than the ammonia ligand, which is the same size as the water ligand, right? You've also got the type of ligand, meaning what they're doing now is they're getting into, monodentate or unidentate ligands, or bidentate ligands, or multidentate ligands. All right. And what they're really testing is, do you understand the concept that all lone pairs aren't bonding lone pairs? You can have lone pairs, for example, on an oxygen atom that is part of the ligand, but on the other hand, it's not part of the bonding lone pairs. All right. This is where the monodentate, the bidentate, the multidentate ligands come in. Right. Now, The next bit then, and this is a bit that I think is crucial for explaining this bit, the next bit is the concept of the D subshell splitting. Right. Again, they do tend to gloss over this a little bit in A-level chemistry, but you know what? You can explain it in about 5-10 minutes. And the idea is this, is that the D subshell, all right, then the D subshell orbitals, yet they split like high energy and like low energy orbitals when they interact with a lone pair from a ligand. And the bonding that you're talking about is dative bonding. And so again, if you don't understand what dative bonding is, well, then you got to go back and like look at it, don't you? All right. And so this is what I mean then by number one, you've got the you've got the concept, like like the conceptual clarity all the way up the top. This is the main concept that's being taught in this module. For example, shape of complex ions, and then below it you've got the supporting concepts. All right, and it's called concept stacking. You can actually stack concepts together, and so all the concepts I just mentioned, all right, they're all linked to the main concept in what's known as a synoptic link. Right. Now, below that then is what I call, what you need is a crystal clear pathway. All right, because anybody, look, parents, anybody can pop onto YouTube and just put up a video that explains shapes of complex ions. Your child can easily find that. Probably like the bus ride home on their phone. It's not going to help them get the A or the A star. All right. Anybody can explain the concept and gloss over the supporting concepts. But what's embedded into all of our courses that empowered STEM, every one of them, doesn't matter, we're talking about chemistry today, like, year 12, year 13 chemistry, it doesn't matter, is our tutors do this. Number one, they explain the concept, like I just did, like the top level concept, like, shapes of complex science. And then they make sure that your child understands the supporting concepts. All right. If they need to go back into the course and they need to like look up something in order to make sure they understand it, or come down to help session, they can. But then the tutor, he makes sure, or she makes sure, that there's this synoptic link between the supporting concepts and the main concept. But most importantly is that your child is then given a crystal clear pathway. And so that's explained, the taught, this is the supporting concept, this is the main concept, and here are practice questions that you can do that reinforce what you need to know to get the question right in the main concept. And parents, like, I'm not just talking about, you can pop out to the internet and you can download a pack of past paper questions. No, what I'm talking about is curated questions that's put together by our tutors who've been doing this for a long time, like a decade. They've been teaching online courses for like 5 years, and they really understand the exam board. It doesn't matter if what your exam board is, all right, it always works, because what they do is that they curate everything together for your child. Your child has practice questions, they understand the supporting concept, they have a clear pathway that allows them to understand, have conceptual clarity with the main concept. And then this is how they start to walk the path, the proven pathway to the A star in A-level chemistry. All right. So look, and what I've been saying, is making sense. You go, yeah, actually, Graham, you know what? I can see how a revision course such as yours is going to be far more beneficial than one-on-one tutoring. What you're saying today resonates with me. I get it. All right. Then look, what you need to do is this. You just need to reach out to us. And it's really simple. Look, it doesn't matter what platform you're watching this video on, this live stream is on Facebook or YouTube or whatever, okay? Reach out to us on the platform or on Facebook. Just send us a message. And look, a member of my team will reach out to you, to have a quick conversation with you, book you in for a call with me. And then what will happen is this, is I'll explain to you, your spouse, and your child on the call, your teen on the call, all right, how we can help your child earn the grade that they want in A-level chemistry. So we can take them from where they are in the mark book up to their predicted grade, up to their aspirational grade, up to the A star in A-level chemistry in less than 16 weeks. All right. So look, hope I answered the question about conceptual clarity, how we use conceptual clarity and a crystal clear pathway and the supporting concepts all rolled into one to help your child make sure that they get the maximum marks they can on the exam. All right, take care. I'll see you on the next one.